Okay, we're going to be looking at linear inequalities in one variable and interval notation here. And we're talking about a linear inequality in one variable. When we talk about inequality, really we're talking about less than, greater than, less than or equal to, greater than or equal to. These are all our inequalities. So basically, an equation has an equal sign. We can also have not equal inequalities, but an inequality has one of these signs. So we look at it when we look at a linear inequality in one variable, which we're talking about. We would look at this as ax plus b is less than c. Now a cannot equal 0, and a, b, and c all have to be real numbers. Okay. So basically, we look at something like this. What we're thinking is, what's something that would make this true? And to give a simple example, we could say, well, what if we have something like x is less than 2? Well, if x is equal to 1 and 1 is less than 2, well, that's true. So that's okay. That satisfies. When x is equal to 0, 0 is less than 2. Well, that's true too, so that's okay. What about when x is 5? Is 5 less than 2? Well, no, it's not. So that's a false statement. And this is what we want to look at with regards to these inequalities, is we want to see situations where we have true and false statements. And we'll look at these a lot of times on number lines. So, for example, you remember the number line here. And we may have 0, 1, 2, 3, and 4. And here, -1, -2, -3. Etc., etc., etc. So this one we had over here, we had x is less than 2. Okay. Well, if we want to put this on a number line, there's a few things we need to know first. And we're going to be using some symbols here, and they're not hard symbols. We have parentheses, which means we're non-inclusive, and I'll explain that in a minute. We have brackets, say we are inclusive. So when we're looking at this, we're saying x is less than 2. And what if x is equal to 2? Well, is 2 less than 2? No, it doesn't work for us. That's a false statement. So we know 2 is an inclusion in there, but 1.9999999 is less than 2. So in this case, we're going to this 2 isn't included. That's non-inclusive. 2 is also just shy of 2, I should say, is the largest value we can have to make this a true statement. So if we think about it in that sense, when we know 2 is non-inclusive, we put a parenthesis at 2 and an arrow pointing to the left, meaning anything less than 2 makes this true and satisfies that. Now, how do we write this? How do we put this in what we call interval notation? Well, in interval notation, one other symbol we need, and that's the infinity. And what this tells us is that we can go on forever this way. It's still going to be statements true. Infinity has no end. So if anything less than 2, well, would solve this. And we can go infinitely smaller and smaller and smaller in numbers and still have a true statement. So if we want to do this in interval notation, we know the largest number we can get to is very close to 2, but not including 2. So we have a parenthesis and a 2. The smallest number would be however far we can go infinity. So we put an infinity there, and we put the parentheses because infinity we can't put a boundary on. We can't say it's included because as soon as we get to the smallest number we can realistically think of, we subtract 1 from it, and now, oh, we've got a smaller number still. So let's look at another quick example here. Let's say we have x is greater than or equal to 4. Okay, here's a number line. We'll put 0 here, -1, 1, 2, 3, 4, 5. So x is greater than or equal to 4. Well, what does this mean? Well, what if x is 7? Does that work? 7 greater than or equal to 4. That's fixed. What if x is 3? Is 3 greater than or equal to 4? No. What if x is 4? Is 4 greater than or equal to 4? Well, yes it is. It's not greater than, but it is equal to. So in this case, 4 would satisfy this inequality and is included. So we're saying x is greater than or equal to 4. Now is when we're going to look to use a bracket, and brackets are inclusive over here. So the smallest value we have would be 4. Anything smaller than that makes this a false statement. Anything larger makes it true. So we put a bracket at the 4, open to the right, because we're going anything larger than that with an arrow pointing that way. If we want to do this in interval notation, okay, the smallest number is 4, we put a bracket of 4, comma, and then we're going to infinity, open parentheses. So this is a little intro, little explanation of inequalities, linear inequalities specifically, and how we use interval notation and number lines to identify these. So I'll see you in the next video. It's all going to be about looking into and solving more of these linear inequalities and what we'll do with them. So have a good day. Bye.